Hello all, welcome to VJD Academy. This is Anil Kumar, Faculty of Digital Electronics. Today I would like to teach one more new concept called minimization, or also we can say that minimization of a digital circuit, or also we can tell that minimization of a logical expression. Sir, let us try to take minimization concept. Before going to understand what is the meaning of minimization and how to minimize a logical expression, how to minimize a logical circuit, and what are the basic methods to minimize any logical circuit or logical expression, I would like to explain what is the basic need of minimization. Let us try to understand what is the basic need, what is the basic requirement, and also we can say that what are the basic advantages of minimization. Let us try to understand first, and then we will see how to minimize a logical circuit and what are the methods to minimize a logical circuit. Sir, let me take to understand the advantages or basic need or basic requirement of minimization. Let me take one logical expression and I would like to explain what is the need of minimization. Let me take here one logical expression. Sir, we know that here y equal to a bar b plus a into b bar. We know that this is a expanded equation of XOR gate. We can say that. We can also write this equation y equal to a XOR b. Sir, I want to draw a logical circuit for this particular equation y equal to a bar b plus a into b bar, and also I would like to draw a logical circuit for y equal to a XOR b, and then we will understand what is the need of minimization. So the moment when we look at this first equation y equal to a bar b plus a into b bar, we have three portions here. The first one is here a bar into b. We can say a bar into b. This is what the first one, and we can say that a bar is multiplying with b, or we can say that a bar into b, which means we are using one AND gate here. AND gate we are using, and also the second part a into b bar, we can say that here also we are using one more AND gate, and finally we are just adding these two components a bar into b and then a into b bar. When we add these two, we are having one more logical gate, we can say OR gate, and then internally as a separate part, if you can see here a bar, which means one NOT gate here, and then here b bar, one more NOT gate here. Let us try to understand the structure of this logical expression. Sir, I would like to draw the logical expression by using here NOT gate, AND gate, and also by using OR gate. Here see, this is a and here b. From a, I would like to draw one NOT gate, so that this will become a bar. To implement this first part, sir, I want to take one connection from here b. Now I would like to add these two a bar and then b to one AND gate. This is what the output of y1. We can say that y1 equal to a bar into b. And now let me take the second part here, which is a into b bar. So what I am trying to tell here is, to understand easy, I want to take one more new color here. Here a, this is what a, and then second part is here b. We can say b. Here the second part contains b bar, which means I want to take one NOT gate here, So finally I would like to connect these two, a into b bar, which means one more OR gate, one more AND gate. Sir, this is what a into b bar. Here this is a and then this is b bar, and now here a bar and then this is b. Directly we can say that the output of the second part, I can say this is y2 equal to a into b bar. Sir, let us try to add these two, y1 and then y2, by using one OR gate here, because we are using one OR symbol. So what will happen, sir? This is OR gate, so the final output is y equal to, we can say y1 plus y2. This is what the final output. Now let me try to explain here. Here y equal to, we can say that y equal to y1 means a bar b plus here a into b bar. So this is what logical expression. From this logical expression, let me try to explain few things here. To construct this logical circuit or to implement this logical expression, how many number of logic gates are required? Here, sir, we have two inputs for this particular circuit. Number of inputs, we can say 2. First thing is number of inputs are 2. And then here second point is number of logic gates required to produce this output y. Here the first logic gate NOT gate, and second logic gate here also one more NOT gate, and third gate is here AND gate, and then fourth gate is here one more AND gate, and final output to produce here we are using one OR gate, which means to produce the output y equal to a bar into b plus a into b bar, we are just using number of logic gates, sir. Logic gates we are using 5 logic gates we are using. And one more thing here, to implement this particular logical expression, sir, how many number of logical connections we are using? Sir, the first connection from A to NOT gate, and then here the second connection NOT gate to here we can say AND gate, here second connection, and B to AND gate, this is third connection, and then fourth connection we can say A to one more OR gate, we can say this is fourth connection, and here B to NOT gate, fifth connection, and NOT gate to B, or we can say OR gate, this is sixth connection. Finally we are taking one more connection from Y1 to here OR gate, we can say this is called seventh connection, and this is eighth connection, and finally to produce one more connection from here we can say OR gate to here Y, we can say 9 connections. Sir, number of connections required, number of connections, or we can say total number of connections are 9, and to produce one single output. Sir, here number of inputs are 2 and output is we can say only 1. So to produce one output by using with the help of 2 inputs, we just need to use 5 logic gates and then 9 number of logical connections to implement this logical expression. Or another hand, let us try to understand, sir, this is what y equal to a XOR b. Of course, this is what standard form, y equal to a bar into b plus a into b bar. Let me explain, when we are learning about Boolean algebra, what is standard form, what is canonical form, what is minimal form. Let me try to explain all those things when we are dealing about Boolean algebra. As of now, let us try to understand this is a standard form, or we can say expanded form. And now coming to y equal to a XOR b, we can say that this is called a minimized expression, or minimized or minimal form. Here y equal to a XOR b. Sir, to implement this logical expression, sir, we just need one is a and then b. These are the 2 logical inputs, we can say. Sir, to implement this logical expression, we just need 2 inputs and then only one gate, that is called XOR gate. XOR gate. This is what XOR gate. Y equal to a XOR b. So this is what y equal to a XOR b logic gate. Sir, let us try to compare these 2 gates. Here this is what standard form, or we can say expanded form, and then this is called minimized form, or we can say minimal form. The moment when we minimize or minimal form, when we consider how many number of logic gates required to implement this logical expression, how many number of logic gates are required, how many number of logical connections are required, let us try to understand, so that we will come to know what is the need of minimization. Sir, I would like to list out the advantages, or we can say the need, or we can say the requirements of minimization. Sir, the moment when I consider this first circuit and then second circuit, how many number of logical gates we are used here is, here we used 5 logical gates, here we are using only 1 number of logic gates. So based upon this, we can say I would like to write here advantages of minimization. Sir, the moment when I minimize logical expression, and after minimization, if I want to construct a logical circuit, the number of logic gates required to implement that particular minimized logical expression is very less. Here, sir, here number of logic gates required is less, decreased we can say. And then number of logic connections we can say here, to implement this logical expression we just need 9 number of connections, and to implement this logic circuit we just need only 3 connections. First one A, B, and then this is what 3. So here number of logic connections are also reduced. And then coming to third advantage, we can say that here the moment when number of logic gates are reduced means the size, or we can say size of the circuit is automatically reduced. The moment when size of the circuit is reducing means automatically the cost of the circuit is also reduced. Cost of the circuit is also reduced. Here the number of logic connections, sir, physical connections are reducing, and then physical quantity, which means number of logic gates are also, hardware is completely reducing, which means cost of the circuit is also reduced. Sir, one more thing, or we can say that the moment when number of connections are reduced, number of logic gates are reduced, size of the circuit reduced, which means the required power to operate this particular logic circuit is also reduced. I can say that power consumption is also completely reduced. Sir, these are the basic advantages when we made minimization process. Now let us try to understand what are the basic methods we are considering to make minimization process for this particular digital electronics. Sir, basically we have 3 types of methods, which are, first one is Boolean algebra, and then second one we are considering K-map, also we can say that Karnaugh map, and then third one we can say that Quine-McCluskey method, or also we can say that tabulation method. Sir, for the sake of understanding or to minimize any logical circuit in the digital electronic subject point of view, we are just considering, or we are just dealing with these 3 minimization methods. Let us try to understand one by one, and what are the basic advantages, and what is the limitation of each method, and what is the capability of each method. As I said, we have 3 types of minimization techniques, or we can say 3 types of methods. Let us try to see what are those 3 types of methods and what is the capability of each and individual method. Let us try to understand. So basically we have 3 types of methods, which is minimization of any digital circuit. We have 3 types of methods. First one is Boolean algebra. This is what first method, and then second method we can say that K-map, or also we can say that Karnaugh map, and third one we can say that Quine-McCluskey method. This method is also called as tabulation method. Sir, the moment when we look at Boolean algebra, basically it can consider, or we can say it can take 2 inputs. The number of inputs it can consider up to 2, which are almost 0 and then 1. And now the number of outputs it can produce, either 0 or 1. This is what the capability of Boolean algebra. And coming to K-map, sir, it can take up to here number of inputs. It can take 1 variable, 2 variable, 3 variable, 4 variable, up to 5 variable it can take. And coming to output of K-map, we can say number of output variables. Here the output of K-map in the form of either 0 or 1, or also we can say that 1 don't care condition. We can see sometimes the output in the form of don't care. So this is the capability of K-map, or we can say Karnaugh map. And coming to Quine-McCluskey method, sir, the number of inputs it can take up to any number. We can say here Boolean algebra up to 2 inputs, 2 variables it can only accept and it can only deal. And now coming to K-map, it can deal up to 5 variable. And coming to Quine-McCluskey, here the number of input variables it can take up to n number, or we can say any number. And the output it can produce number of output variables, sir, there are here 0 and then 1. We can also see here don't care condition. This is what the capability of Quine-McCluskey method. Of course, mostly we are dealing with K-map because there is lot of disadvantages in Boolean algebra, which means it is not able to consider more number of inputs. We can say when we apply A, B, C, 3 number of inputs, Boolean algebra capabilities may be reduced, so that we are just approaching K-map to deal with bigger expressions, or we can say bigger logical circuits. We can deal with K-map. And sometimes when we look at more than 5 variable, or we can say 6-7 variables, we are just using Quine-McCluskey method. So let us try to understand each and every individual logical minimization method, and we will see number of theorems and then equations, and then what are the standard forms, canonical forms, and all those things we are going to see. Thanks for watching. Please do subscribe.